um, because my network is not that stable this morning. Mm. I don't know if it's my PC or the network, not quite sure. All right. I believe you guys are great this morning, as we agreed yesterday. So today is gonna be the last section of chapter 16. I believe we're going to finish that section today. Not a lot of content remaining. And the weird part with this is that I have already I mean, you guys are the only group whereby I'm making significant progress in covering chapter 16, because I haven't even started this chapter with the ops group and the transportation group on APB. But it's not a big deal. We're going to make our progress, because I mean, this week, today is also the last our last session, so we're not going to meet after this, like this week, only next week. So yeah, let's see how we can progress today, and then next week we can quickly summarize the chapter again, and then have some calculations. Because remember I told you that the last part of this chapter is gonna incorporate some calculations, but they are straightforward calculations as long as you are here, and I believe you should be fine. All right, ladies and gentlemen, if that is clear, if you guys can hear me, let me quickly share my screen and then we'll take it from there. So again, if you have anything to say, if there is a comment that you want to bring on board in order to enrich this session, please feel free to do so. So I'm gonna share my screen. Um, Let's include the sound. Let me share the entire screen. That's better, so that everything that I'm doing, you guys can see. Ladies and gentlemen, can you guys hear me?
Yes.
Perfect. Thank you. Right. Um, so chapter 16, just in time and lean operations, we have already largely spoke about the just in time philosophy. We also spoke about lean operations and TPS, right? So you need to be able to come up with some kind of differentiation between just in time, lean operations, and TPS. Please make sure that your mics are off if you are not going to say anything. Okay, so as I was saying, so you need to be able to differentiate the just-in-time philosophy from the lean operations, and also from the TPS, which is Toyota Production System. And what we are doing here, the just-in-time, as I said, it originated from the Japanese industry, so specifically from the Toyota Motor Corporation, right? So now these are the practices that we are teaching you so that you can implement them in your different workstation, or you could implement them when you be employed as a manager. So equipping you with that kind of knowledge. All right, so we have covered all this, and I think we also spoke about reduce space and inventory. So today we're going to take it from Kanban. So we're gonna speak about Kanban. Let me slideshow from current slide. All right. So Kanban here, it's a Japanese term, right? And it means card. So in this card here, it can also be called as a container, right? They say the card is an authorization for the next container of materials to be produced. So a sequence of kabans pulls material through the process. Many different sorts of signals are used, but the system is still called a Kanban. So what is happening here? You can see on this picture on your right hand side, I think this fast food restaurant, let's assume that is probably McDonald's, right? Let's assume that this is McDonald's. So this, what is happening here? You see there is an employee from McDonald's who's currently serving the first car by the employees by the window, handing out the order to the customer, or the food to the customer in the car in front. So once this customer is served, or once this customer has received his or her order, the customer will drive away and there will be an empty spot. Guys, please ensure that you switch off your mics unless if you want to say something. If you're not going to say anything, please just switch off your mic, because it's a bit irritating while I'm talking and I can hear noise coming from left and right. Right. So once this customer, I don't know, there is a kind of noise, like, I don't know, mic is on, or let me just stop sharing and share again. And I will probably share without the sound. I don't know why it's making that noise. Yeah, it was a bit noisy. Yeah, I think it's better now from the current slide. Yeah, so as I was saying, so on this you'll see a customer is going to receive their order, and then the customer will drive away. Once the customer drives away, there will be an empty spot for the next car to come in and collect, the next customer to come to that empty spot, right? Or drive to that empty spot and receive the order from the employee from McDonald's. We assume that this is McDonald's. So that empty spot, it's a kind of a signal that is telling the customer the customer at the back, that you are needed. You need to move forward in order to receive your order. And it's also a signal to the employee that the next customer need to be served. The next customer need to be served. So in this case, what is happening here, that process of empty spot being filled in by the next customer, and also the employee being informed that the next customer need to be served, is now what we call a Kanban. But there are different, sorts of Kanban. For example, in the manufacturing area, if I can go back quickly to the pull system, just to illustrate this concept of Kanban. The pull system, I don't know, we spoke about the pull system where, yeah, right. You can see from this uh, um, representation here of the pull and the push system, but obviously we are talking about the pull system, not the push system, because in the push system here, this operator here, once it has processed this material, right, at a certain level that is designed for this workstation, now this operator is going to shift that material to the following workstation, right? The following workstation. For this, once this place here is now empty, meaning that the material has shifted to this operator, meaning that this space is now empty, this operator need to process another one in order to fill in this empty spot, so that it keeps going like that. So the Kanban system, right, or card is linked to the pull system, right? So if these two operators here, I mean operating the two different workstation, if they can see each other, right, they could just use the empty spot whereby they put the material inside and then they are pulled to the next workstation. If it's in an environment, in a workplace whereby they cannot see each other, usually it's even a sound, right, or a light that need to signal to the upstream workstation that you need to send the material downstream so that the work can continue. So let's take an example, for instance, of the retail market. For instance, Pick and Pay. Let's say you go to Pick and Pay, you want to go and buy a bottle of milk, for instance, and that is the only bottle remaining there. Once you take that bottle, that space whereby they have to store the milk, right, will be empty. So probably at the end of the day or during the working hours, an employee from Pick and Pay working in the aisles, ensuring that the product are present on the shelves, will notice that there is I mean, some product are depleted. Let's say milk is not available, right? In that case, I mean, that employee will go to their storeroom and, refill the empty shelves with the appropriate milk that is missing, that is depleted. If now in case they find out that, okay, they don't even have milk in store, what is going to happen? That is going to trigger their main and that's, I mean, inventory center, right, to send the milk to that specific retail market. What about if by their distribution center there is nothing, so that you need to go back to the production, so meaning that that product is needed. So this is also a kind of Kanban system that you are talking about. So that's why in the statement here it says that different sorts of signals let me go back. It says many different sorts of signals are used, but the system is still called Kanban, right? So a kind of pull system that is informing the upstream workstation that there is work or there is an empty spot or the next container of materials in needed downstream, and then the production can continue. So those are some of the ways that you should think about when it comes to the Kanban approach. Now, let's try to illustrate again the Kanban system from here. we have this representation here, or this figure. From this figure here, you have employees working in different cells or at different workstation. We have employees working here. These employees, once they are done with their process, they are going to shift whatever they have done here to the downstream workstation. So the downstream workstation here will be the sub-assembly, or it will be the final assembly. So depending on the process. So let us assume that what they have processed here need to go to the sub-assembly to these two operators here. So they are done with their process. They will shift their materials to this sub-assembly. And that now will tell them here, because once they shift whatever they have produced here or whatever they have done here, they will be idle. So they will be ready to receive the next batch of materials. So what is going to happen? They are probably going to press the system, right? Press a signal to tell the upstream workstation, or the supplier in this case, that we need materials here at this work cells or at this workstation, right? So that will trigger the reaction from the supplier to provide this workstation with the raw material so that they can proceed with their work. So, and then it keeps going like that. It's like a cycle, right? Once the work is done here from this work cell, that is shifted to the downstream workstation, which is the sub assembly. And then here the work cell will request the raw materials to be sent again. And that is also done here at this sub assembly level. Once they are done, their materials are shifted to, or sent to the final assembly. And again, there will be a signal to tell the work cell that, hey, this workstation here, the sub-assembly, is ready to receive the material. So again, this also illustrates the concept of the pull system, whereby it need to make sure that the downstream workstation is ready to receive the next batch of materials. Please switch off your mic. Right, so that is just to illustrate the concept of Kanban, right? Now, what are the advantages of using a Kanban system? It said it's allowed only limited amount of materials, because remember the Kanban can be also used using a, because it's a component of the just-in-time philosophy, right? And you know, when you are using a just-in-time or following a just-in-time philosophy, the company or the purchaser uses materials in small quantities. In other words, the company reduces its inventory level, or can. I want to check if there is an option where I can mute all of you guys. Yeah, just settings. Let's go to settings. Mute notification now. Meeting settings option. Choose row who can present. Okay, that one won't mute all of you. Enable your interpretation. That one. Allow mic for attendees. No. Allow cameras for attendees. No. All right. I think we should be good now. So you guys, what you're gonna do if you want to, somebody said that you cannot hear me. At this point, if you want to say anything, it's better use the chat there, or even you send me an email if there is a problem, because you guys are disturbing me. So yeah. All right. So let me quickly go back to what I was saying. So now we're gonna talk about the advantages of Kanban. So it says that it allows only limited amount of materials, because remember in that pool system, only a small lot or small container of materials is allowed in a sequential manner through the process. They say problems are immediately evident, right? So moving materials in small lots reduces the need of inventory. So if there is an issue in the process, right, or with the materials, the company can easily, or the operator can easily spot that. They say put downstream pressure on bad aspect of inventory as the process is flowing. If there is an operator that is not operating according to the set standard of the company, that will definitely be picked up. And that is where sometimes when there is an operator who's not performing according to the company set standard, the operator usually provided with the kind of reskilling or upskilling exercises in order to ensure that they are capable of delivering on the company's objectives. Standardized containers reduce weight, disposal cost, wasted space, and labor. So again, having a standardized approach, it's also easy for the operator to already know the kind of quantity that is going to be received and what is going to be also passed through the downstream workstations, right? So very critical, because this doesn't only speaks to the Kanban approach, but having a standardized process is good for employees to follow the process easily, right? Um, Now we are going to introduce. Remember, we spoke about small lots, containers, batches, and all that. This is now we're going to try to see how do we calculate all this. How do you know how many batches that the company need for a specific process? Ideal situation is to have lot sizes of one pulled from one process to the next. So again, this speaks to the Kanban system, which uses the pull system, unlike the push system, right? You see the EOQ here is the economic order quantity analysis to calculate the desired setup time. So we're going to talk about the setup time. Two key changes are necessary: improve material handling, reduce setup time. So what is setup time? So setup time is the time it takes to prepare um, machines for production, right? Could be the first testing of the machine to produce the first product, and then check if the settings are correct before the actual, production takes place, right? So the EOQ here is the kind of the quantities of the materials that the company need, right? So how many orders that the company need to make in order to keep the production going, right? So now let's look at this uh, statement here. So here we're going to calculate the lot size, going to calculate the setup time, right? And we can also calculate the setup cost. Obviously, we're going to calculate the setup cost. Now, we're going to make use of this big formula here. Say Q is equal to square root of 2ds divided by h between bracket 1 between bracket 1 minus small d divided by small p. So this exercise that we are going to do here is to determine the size of the container, right? Also the quantity of item that the company need in order to keep the production going. So let's go back to this statement here that you have. So in this case, we are going to calculate the setup cost. If you are also asked to calculate the setup time, you can also calculate the setup time. So let me explain what's going on here. Here you have the annual demand for this business is 400,000 unit. All right. So this is the annual demand, the demand from the market that the company need to satisfy. 400,000 unit. Small d here represent the daily demand, right? So this is the daily demand that the company need to satisfy every day. Now, in some instances, they can be so explicit and tells you everything. But yeah, if the daily demand is, the annual demand is 400,000, probably they will tell you the company opens 250 a year, right? If the company opens 250 a year, that means that your daily demand will be 400,000 divided by 250, and that will give you the daily demand. So here in this case is 1,600 unit per day that the company need to deliver to the end user or to their customers. All right. So small p here represents the daily production or daily production rate if you want it. So this is what the company need to produce daily or the daily production rate, 400,000 unit, right? Now, the EOQ here is the the size of the container, right? Remember when I was talking about the pole system, I said that it could be a container, and in that container, you have materials that need to be shifted from the workstation I'm from workstation 1 to workstation 2 and so on, right? So this is the currently the size of that container. H is the holding cost. So in this case here, the holding cost is provided. But what is the holding cost? So the holding cost here are cost related to the inventory, right? The inventory that the company is keeping. If there are damages, spoilage, or expired product or raw materials, those are what you call holding cost. On the other side, you will have the setup cost. So I've already said that the setup costs that are related to the preparation of the machines for production. They are also called ordering cost, right? So when the company is preparing the paperwork, right, to buy raw materials, from suppliers, all those costs related to the preparation of setting up the order in order to buy materials or raw materials from suppliers, yeah, those related costs are called setup costs, right? So now In this case, you have the holding cost of 20 Rand per unit. All right. And the setup cost here is what we need to determine. And also we are going to determine the setup time, right? So this is the hourly labor rate. So what employees need to be paid per hour, right? So now, based on this formula here, this formula is also well explained. Not even this formula, I mean this part of the content is also well explained in chapter 12, which talks about the inventory management. So if you have the textbook, you can go back there and have a quick read at that section. I'm sure you're going to get a better understanding of how to make use of this formula. So now, based on this formula, this is the size of the Kaban, which is also called the EOQ, the economic order quantity. So here we're gonna take the square root of 2 times the annual demand multiplied by the setup cost divided by the holding cost. Between bracket is 1 minus small d is the daily demand divided by small p, and then you close the bracket. Now, in this case here, what are we looking for? Let's say we are looking for the setup time. We want to calculate the setup time. So here's also what you need to understand, guys. If you are asked to calculate the setup time in this kind of scenarios, you cannot go straight and calculate the setup time. You need to calculate the setup cost first. And then after calculating the setup cost, now you calculate the setup time. So what is happening here is that you can see from this formula, we want to calculate the setup cost first, and this is the setup cost. So you can use your ingenuity here in order to pull this setup cost from the formula, right? That is what is done here. So what is happening here, I'm gonna just explain quickly from here. If you want to remove this because you want to pull this S from, from this side, because that's what you are looking for. That is the value that you want to calculate. So in this case, square root of this, not square root, q power of 2, you also put here q power of 2, the square root will disappear, and that's why you have this part here. So q power of 2, and on the other side, the square root is gone. So now you have an equation whereby you just need to solve for x. So pulling this x here. So that's why if you have to pull x here, in other words, you can just take this part here, q power of 2 times 1 over h between bracket over all this part here. Let me quickly do that. If let me see, can take my pen. So here what is happening here, in order for you to get the setup cost, what is going to happen here, we're going to multiply this side here by 1 over 1 over h. I don't want to write all this. So, but here it's 1 over h, this part, right? Multiply by q power of 2. And also the same thing, here you also multiply by the same 1 over this one here, right? So what is going to happen here? So you're going to simplify. Hey, hold on, guys. Da, 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 da. No, 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 no. You're gonna multiply here by h, sorry, not 1 over h. Let me just go back quickly. Take erase. not 1 over. Because we want to multiply in a way that we can cancel so here, what is happening is that you want to cancel this one out. So this one will be multiplied by h between brackets 1 small d over small p. Guys, I thought that I switched off all your mics. And since you multiply this side by this expression here, you also need to multiply this side as well, so that you don't make any changes to the equation. So the changes that you make on the left, you must also do the same thing on the right. So that is h between bracket, it's 1 minus small d divided by small p, right? All this times q power of 2. All right, so in this case here, you can see this one will cancel out or this one. So you'll be remaining with h between bracket 1 minus d divided by small p, close the bracket, times q power of 2. And on the other side here, you'll be remained with 2 d. So you'll be remained with something like this. So it will be h let me put the bracket 1 power 1 divided by p times q power of 2, right? And on the other side, you're gonna have 2 ds. Now, what are we looking for? We are looking for this s. So in this case, we're going to multiply, right? Again, we're gonna multiply this side here by because you want to get rid of this 2d from this side so that you'll be remaining with s. So that is gonna be 1 over 2d, and here also you're gonna multiply by 1 over 2d. And obviously this one will cancel out, right? And then your final answer, which will be now s, will be this value here to now give us this formula. So that's if you want to demonstrate the formula, because I believe you're gonna have a question whereby you'll need to demonstrate or something like that. So now this is the formula of the setup cost. So after calculating the setup cost, you will be able now to calculate the setup time. So what I'm gonna do, let me just erase this, erase all on the slide. Yeah, that's good. Right, so now this is what we have. Since you are calculating the setup cost, so this is the formula that you're going to use every time when you are asked to calculate the setup cost. So the Q power of 2, we already have the Q here. Q also could be your Q. So that is 400 power of 2. Between bracket, you're going to have H. So H, the holding cost, which is 20 Rand. So we're going to put 20 Rand here. And between bracket, you're going to have 1 minus small d. So small d is the daily demand. Here is 1,600 divided by small p. Small p here is 4,000, right? And divided by 2 multiplied by the annual demand. So the annual demand here is 400,000. So that is 2 times 400,000. So if you do your calculations properly, or let's just try to demonstrate quickly what is here on our screen. Can pull my calculator. So let me put it aside. So here we're gonna have I will start with this portion here. D, how do you call this? D, small d over small p. Or what I can have 1 minus small d here is 1600 divided by small p here is 4000. This is the answer, right? So of this portion here, 1 minus small d divided by small p. This is what we obtain. So that is 1.6, right? So you say times the h. So h here is the holding cost, and the holding cost here is 20 rand. So gonna multiply this by 20. So that gives me 12, right? Now on this side here, it says q power of 2, and here we have q here, right? Q power of 2. So I'm gonna say times q, or I can even say 400 times 400, right? That gives us what? 1,920,000, right? So divided by 2D. So 2D here is 2 times 400,000. So that is, it's going to give us obviously 800,000. So if you want, you can just put all that down. So that is 2 times 400,000. 400,000. And that gives us 2.4 rand, because we are calculating the setup cost from here. And then, I mean here, from here, we will now move on to the setup time. So this is what we obtain, 2.4 rand as the setup cost. Now, in order for you to calculate the setup time, right? Since you have already calculated the setup cost, you can now calculate the setup time. So in order for you to calculate the setup time, you are going to make use of this labor rate, which is 30 rand. So you're gonna take the setup cost divided by the labor rate. So here in this case, that's what you have 2.4 rand divided by 30 rand per hour. And that is going to give you the setup time. Here's what is also important. Whatever calculations that you are doing here, the unit is in hour, right? It's in hour. Taking 2.4 divided by 330 to give you 0.08 hour. So if the question, for instance, is asking you to express the setup time in hour, right? That's fine. So you will leave it like this. If the question is being specific, saying that express your answer in minutes, for instance. So that means you will now need to convert this 0.08, right, into minute. So what you do is this simple approach whereby you take 0.08 times 60, and the answer that you're going to get will be now in minutes. So again, obviously during our test, as you know, you're not supposed to write the unit according to the instructions. So even if the question says that provide your answer in minutes, for example, in that case, you're gonna do these calculations, right? 0.08 times 60, and this will give you 4.8 minutes. And when you're going to fill the blank, you just exclude the minute in this case, right? So yeah, so now this is the setup time that you have calculated based on the information provided in the statement. Now, let's move on to the next type of calculations. So here we calculated the setup time and the setup cost. So still you'll be needing this formula, depending on the scenario. Or what I wanted to say is that there are two main formulas for these calculations. You have this formula here of the EOQ, right? Or the Q, which leads or gives you the option to calculate the setup time, the setup cost and the setup time. Now, the next formula is now to determine the number of carbons, and you could also be asked to determine the carbon size, all right? And if you're asked to determine the carbon size, you'll go back to this formula here. All right, so now it said the number of carbons card or containers. Need to know the lead time, right? The lead time needed to produce a container of part, right? Need to know the amount of safety stock needed, which could also be called the buffer stock, right? And I also wrote some, some notes here for us to understand. You see, safety stock or buffer stock is the extra inventory of materials, work in process, or finished goods held to safeguard against unforeseen disruption to the supply chain, such as sudden surges or delays in supplier deliveries. All right, so that is a buffer stock, a small kind of inventory that the company should have, in case there is a delay in the supply of materials. Now, let me just make it in the slideshow, current slide, so that it can be seen clearly. So, in order for you to determine the number of carbons or the number of containers, you will have to know the demand during lead time. You will need to know the safety stock and the size of a container. So these are the three elements that you need to know in order for you to determine the number of containers that the company need to have or need to process in order to produce a specific given amount of product per day or per year, depending on the scenario. So let's look at this example here in order to see the practical application of this formula. So in this scenario here, you have the daily demand, which is 5 cakes. Again, this is what the company need to satisfy on a daily basis. And you have the production lead time, right? The time it takes from ordering a product or when the product enter the process until the finished good comes out of the process. So here it says that the production lead time, you should consider the wait time or the waiting time. No, the wait time. The wait time plus material handling time plus processing time until the finished good comes out of the process, right? So that is the production lead time. So in this case here, it's given is 2. So you have 2, gives us 2 days, right? So the lead time. So it takes 2 days in order to complete a specific process. So that is 2 days. Now, safety stock, again, the buffer stock that the company need to have in its facility in order to anticipate any delays, or disruptions in the supply chain. Right. So here is half day. Usually it's half day of daily demand, right? So safety stock half day of daily demand. In some instances, you can also talk about half day of daily production. So just be a bit careful there. If nothing is said, you say half day of daily demand, but they could be very specific there. So container size is the EOQ, or the economic order quantity, or simply the Q. So that is 250 cakes, right? So now the formula is telling us that in order for you to calculate the number of Kanbans or containers, you need to have demand during lead time plus safety stock divided by the Kanban size. Right. Now, how do you calculate demand during lead time? So demand during lead time, we are going to take the lead time that is usually provided, right, multiply by the daily demand. So here's our daily demand here is 500 cakes. Our lead time is 2 days. So we're going to take 2 times 500, right? So 2 times 500. And this is also called the maximum inventory. In some textbook, it will be called like that, the maximum inventory, right? So now, once you have the demand during lead time, in this case here, 2 times 500, so that gives us 1,000. So once you already have the demand during lead time, so you just need to replace, um, I mean, 2DL here, demand during lead time, with 1,000. So here you have 1,000. And safety stock, that becomes also interesting. Safety stock here, it's given in days, right? They say half day of daily um daily demand, half day of daily demand. So what you're gonna do here, here's the daily demand, 5 cakes, and safety stock say half day of daily demand. So you need to convert this half day into cakes, into a real product. Here they are talking about cakes. So half day or half day of daily production is what? So you're gonna take this half day or 0.5 multiplied by 500. So that is gonna give you 250. So that is the 250 that we have here. So 250 plus 1,000 divided by the Kanban size. So Kanban size, again, it's provided here. Container size is also Kanban size. Here's 250 cakes. So below here, you're going to have 250 cakes. So this is I don't know. I told you guys about the maximum inventory. Yeah, so this is where the maximum inventory is. So again, in some textbook, they will talk about the maximum inventory. So don't be confused if you see that expression in some of the textbooks. All right. So once you perform these calculations here, that will give us 5 as the number of Kanbans or the number of containers. Now, What is also interesting here is that safety stock sometimes, in this scenario here, it's given in days, right? It could also be given in product. So the reason why we are multiplying this half day times um the daily demand is because the safety stock is not provided in the appropriate unit, because you cannot have 1000 cakes plus 0 0.5 day. You won't be able to go anywhere with that. So you have to convert this safety stock, right, this half day, into real product. So here they are talking about cakes. That's what we multiply. So we are not just multiplying by the sake of multiplying. We are simply converting half day into product. If this company say it's a half day of the daily demand, so how many product? So that's why we multiply, not just doing the multiplication like that. All right, so let's do this. Let me go back again. I don't know if you guys let me do this meeting option. Did I close that meeting option? No. Meeting setting, meeting option. Allow mic, yes. Allow cameras, nope. All right, so I think I have unmuted all of you guys. So if you feel the need of saying anything, please feel free to say so. So yeah, what I'm gonna do now, as you guys said yesterday, you you want some calculations. I'll give you guys a couple of questions here that I would suggest that you can even take a screenshot, or you can go back to the recording in order to maybe pause and then see the question, so that when I'm also done with the other groups, I'll do the same thing. But for now, I'm not going to post them online as I'm not done with the other covering the content with the rest of the groups. So you guys should take maybe a screenshot, I don't know, a picture of this. All right. You can also take this question here, or what I'm gonna do, I wanted to send it in the chat, but it's fine. All right. So yeah, you can open the recording, and then you can see the questions, and then you can work on them. But what I will do is that when I'm done, I'll post them on Moodle. But for your own, self-practicing activities, you can just try this. And I believe you're gonna have time to. Guys, please stop being reckless and then you open your mic. You know that you're in a noisy place. It's reckless and rude. Unless if you want to say something, you can't just open your mic and then you keep quiet. All right. So let's take the attendance register, guys. Quickly, if you guys still want me to project those questions, I will do so. So let me do this. How do you take the attendance register here again? Yeah. Or what you guys can do also, you can, if your class rep is here, you can communicate with your class rep. You can request, I will send the question via WhatsApp. in the meantime, whereby you guys can practice. And when I'm done covering the other groups, and then I'll post everything on Moodle. So let me attendance. Uh, I think it's this one here. Change here. Good. So probably I don't know if you have another device or something. You can just scan here, and I think automatically you can scan this QR code. Automatically it will probably you know record your attendance, or you can input this password here, so 000, and then yeah, you have recorded yourself. So please make sure that you record your attendance. And there is also another thing that I wanted to tell you guys. There is a request from our HOD to follow up on students who are struggling with this module. So what is happening is that um, I'm going to release a list of students who I believe, I mean, not I believe, I do have the evidence that they are not, they need the help. So once I release that list, if you see your student number there, because it will be base student number and initial. So you check your student number. If you see your student number there, please you must come and see me based on the schedule that I will be providing. So yes, just a heads up that something will come your way in that regard. Um, yeah, just give me a second. Let me just stop recording quickly, and then I will go back there. I'll go back to that link. I just want to stop recording. Because I don't need to record this. Stop recording. Perfect.